Assalamu alaikum. Hello viewers. This is the position that we left last time with this our vertical axis wind turbine, but today we will be doing some flow simulations across the blades and across the structure. For that we'll be just removing all the appearances, and since these aren't any of the usage in simulation, but before that, before going to this flow simulations, we need to make a wind tunnel that is usually used to simulate some of the flow patterns of any solid bodies or solid structures. So we need to make one of it, but before that we just measure the distances a little bit to be more precise about our design of the wind tunnel. So it's roughly 7.25 meters in height. So we need to open a new part file. Since that was in the top plane, we'll be sketching on the top plane. We'll be going for a rectangular cross section, dimension it. Since that was the 7.5, it was the maximum dimension of our design. So let's just say we'll be using more than a little double of the dimensions. So let's just add some dimensions here as well. Let's go for the square wind tunnel for the time moment. We just offset the entire part of it. Since its thickness doesn't matter too much, so we'll be going up to a little, let's say 0.5 meters of thickness of the wall, and we now extrude it. We'll be going for 15 out here as well. There, much better. Now we need to save it. I'll just say wind tunnel, and we start a new assembly file. Double click on it, and since both of these files are open in Solidworks, these are the documents that are available for ready importation. Let's just say we'll be bringing the wind turbine now. Click it and just drag and drop it out here, and see this F, it means it's fixed out here, but since we need some of the matings, some of the movements, we'll be just making it float. That means it's not fixed with respect to the origin of the assembly file. So we need to add the wind tunnel as well. So for that we need to click insert component, and we click wind tunnel. Now we need the matings, so let's just say for the time being we go for this plane and this plane. Control press this plane and say mate. Solidworks will readily choose the available mates. So for this is coincident mate, that would be good enough for us. We'll just hit OK. And another thing, since we need it to be in the middle somewhat, we need to see some of the planes, and for that let's see the right plane. Since our design is somewhat unsymmetric, we just roughly go for the mates, select the right plane to be symmetric to these two faces. So for that we go for advanced mates, choose symmetric, choose the symmetry plane as this right plane, sorry. So the symmetric plane is this right plane, and the two other planes will be this one and this one. So it's somewhat middle now. And now we need another mate of these two faces. Let's say we want another symmetric mate where this face and this face would be symmetric. Sorry. Symmetric about this top plane. It's somewhat middle now. It's good enough for us. And in Solidworks you could always just modify the length or the dimensions. For that we just go, if you want just to increase the length of this portion to ensure the laminar and fully developed flow, we just go to open part, and since it's already open, let's say we just edit the boss and select mid plane. Let's just say we want 30 meters. Just control save and it will be automatically updated to the assembly. And now there has been a problem with the mates. Let's see which ones. Oh, this doesn't matter. All we need to just delete it and rebuild the mates since it's just been modified a little, but that won't be a much problem. Now let's just make another mate, symmetric, similar way. The top plane as the symmetric plane for these two surfaces, and Solidworks didn't update it because the distances, the ratio didn't match, and we changed the type of the extrusion, and that was mid plane instead of blind, so that's why I didn't update it as we expected. But if we hadn't changed the type, it would have been updated easily. So that would be right enough. And the another mate, the right plane, let's say symmetric plane will be the right plane, and these two would be, sorry, this one and this one. That's good enough. Now fluid will be flowing from somewhat this direction in y direction, and would be excluding somewhat in the negative y direction as well. So before that we need to enclose this area, but in SolidWorks if we just turn on the flow simulations tab, it would just automatically make a feature, and that would already cope up with this. So we'll be just going to tools, add the add-in for flow simulation. You could always just choose things from here, select OK, and you will be seeing about here and also on here. So now we start a wizard, and before that we need to save the document. Let's say wind turbine flow. Now we start a wizard, and SolidWorks will automatically demand an enclosure. But before that, let's just say set these now as default for the time being. Is SI is the internal, since we are using the wind tunnel, and the reference axis will be Y for us. We add the fluid as air. We assume that this is smooth wall without any roughness. An ideal situation, let's just say in the velocity is initialize the value with something like 20 meter per second, and this is the resolution result option, and the higher you select, the more precision you will get and the more time it would take to calculate. So let's just be satisfied with this. And since this isn't an enclosed body, Solidworks has demanded for the enclosure, and so this is a create leads feature is automatically activated. So we choose the regions that we need to enclose. So we choose these two faces to be created for 2 new leads. Click OK, and the current study or computational domain has changed. So let's just, for the time, we go out here and hide the wind tunnel, make it transparent, and we just want to hide it there. I'll come back to flow simulations. Here we want specific goals, what we need. These are the global goals. Let's say we just need the static average pressure, total pressure, maximum total pressure, and maximum dynamic pressure, and the average pressures. Usually we need the velocities, and we'll be seeing why we need it, since our axis, reference axis, and the flow axis would be y, so we'll be just going for the y-axis ones. We could also look for the turbulence intensity, also heat fluxes, and if you want some of the heat transfer related problems, some forces, frictional forces, let's just say on the torques, frictional forces in y direction. The more you want the simulated results, the more it would just take more times only. And if you want some other features like surface frictions and would choose it, then all you need to do is just insert surface goals to see what surface parameters you would see. Let's say if you want some additional things like static pressure or total pressure of the surface, and we select the surface as, let's say, this one, these 3 blade surfaces along with this one. Now for the boundary conditions, we just select this face as inlet and choose inlet velocity, and let's say we choose 20 meter per second as inlet velocity. Air will flow from this plane and up to this plane. We just assume that it turns into just a atmospheric air stream. So this is pressure openings, let's say it's environmental pressure, and with this face. Good enough. Now let's just run the simulation in this flow simulation bar and leave the other things as default, and you can always change what you need it accordingly, and try to check this new calculations and don't take the previous results. Load the results to see what the results are here. So let's just say run. You could see the convergence, the machine model preparings. You can see the convergence rate, iteration numbers, how they are converging, the current values, and these are usually done in numerical ways using the standard numerical calculations, numerical equations. So here we need iterations, and you can see the plots, and since we haven't set any criteria, so it would shows the relative error, relative convergence, and that is how it achieves its goals. And since we can see the iteration numbers in how many times it's just converged, and we can see this one pressure as iteration number 52 to achieve the outlet boundary condition. And here we can see the iteration numbers. See, so it's finished. Now we can close it. And the results will be loaded. See, now if we want some flow trajectories like velocity profiles, I prefer lines with arrows. And pressure, velocity in y direction, let's say 200. And if you want the starting point to be this inlet face, and create some streamlines. This is how things have changed. It's just too much clumsy. Let's just change the modifications for trajectory, edit definition. Just maybe set this one into 75. Let's check the mark and see. If we zoom in, there are some kind of flow distortions and flow separations out here. So this is where the vortices are formed from. And similarly, if we want the pressure plots, similarly 75 instead of pipes, so it's the lines for this one, and similarly starting point would be this face. We'll just hide this one and see there's a difference in pressure, and this is responsible for bendings. Since there are low and high pressure regions, these would cause bendings in the structures. And for more precise calculations, if you wanted, you could have just set these things according to your demand, according to the fall directions as well. It's just a rough simulation, so we're just not concerned about much of the precisions. You may just go for the goal plots, report animations. You could also see the surface plots. Hide this trajectory as well. And here we can see the pressure region. This is where our pressure lies, and if you want, we just move this thing the position we like to. This is the region, and we could have just changed and checked whatever pressure, whatever surface we'd like to see the trajectories on. So this is the basics, one of the basics to study flow patterns and flow simulations in Solidworks. And you could have just imported or exported the loads, the pressures into some structural studies as well, but that would need a high amount of memory in your computer. Otherwise this wouldn't just be too easy at all, because that requires some meshing, and you need to mesh these surfaces pretty fine. Otherwise the calculations are pretty nasty, so they will not be shown in softwares. So for the time being, we'll be limited to this flow simulation, and that would be all for now. And if you have missed the design situation, how we have designed this one, the link of the previous part would be given in the description below. So if you have liked it, please hit the like button below, please subscribe and share. Thanks for watching.